Welcome to Study Loop.
When constructing confidence intervals for the population mean, we assume that the sample follows a normal distribution or that the sample size is large enough for the central limit theorem to apply. For the first question here, if n equals 16, the sample mean is 70, the sample standard deviation is 10, the sample size is 16, and the confidence level is 90%, which means alpha is equal to 0.1. Then to find the confidence interval for the population mean, we can use a t-distribution since the sample size is small. The degrees of freedom is going to be 1 less than the sample size, so that's 15. The critical value for a 90% confidence level with 15 degrees of freedom can be found using a t-distribution table or a calculator or software, which is 1.753. Now the standard error is equal to the sample standard deviation over the square root of the sample size, so that's going to be 10 over the square root of 16, which is 10 over 4, or 2.5. The margin of error is going to be equal to the critical t-value times the standard error, so that's going to be 1.753 times 2.5, and that's 4.3825. So our confidence interval is going to be the sample mean plus or minus the margin of error. So the sample mean was 70 plus or minus 4.3825. Doesn't say what to round to. I'll go ahead and just keep it 4 decimal places. So we have the lower bound is going to be subtracting 70 minus 4.3825, which is going to be 65.6175, and our upper bound is going to be adding to get 74.3825. There was a second question. If n equals 36, the sample mean being 70, the standard deviation 10, and a confidence of 90%, that confidence level, then alpha is 0.1. Since the sample size here is greater than or equal to 30, then we can use the z-distribution to find the critical value. The critical value for a 90% confidence level is about 1.645. So the standard error, which is equal to, again, s over the square root of n, is going to be 10 over the square root of 36. That's 10 over 6, or 1.6667. And the margin of error is going to be the critical z times the standard error, so that's going to be 1.645 times 1.6667, and that's 2.7417. So our confidence interval, again, is going to be x bar plus or minus the margin of error, which is going to be 70 plus or minus 2.7417. So our lower boundary from subtracting is 67.2583, and our upper boundary from adding would be 72.7417.